Swayam Prabha. Digital India. Educated India.
Sir, you can start your session. You are live now.
Okay, thank you. Let me share my screen first. I hope my screen is visible.
Yes, sir.
Okay, thank you. Welcome to the live session 3 of the NPTEL course Fundamentals of Theoretical and Experimental Aerodynamics. We had started this course in January and we have crossed a couple of months, and today happens to be the last live session of the course. You may recall that the course number is NOC 24AE04. It is a rerun course. That means originally the course was offered earlier, and this is another time that it is running. Myself, the course teacher, Professor Arnav Roy from Department of Aerospace Engineering, IIT Kharagpur. I am ably supported by my team of TA students, Mr. Arpit Mishra and Mr. Arjun Garbha, who are both scholars of the Cryogenic Engineering Center, IIT Kharagpur. They have been very supportive in preparing the assignment questions, preparing solutions to them, supporting me in different possible ways to conduct this course very smoothly. And we have been very ably, efficiently supported by a host of staff members from the NPTEL team at IIT Kharagpur, as well as at IIT Madras, along with a whole lot of faculty members who are also working to support us make this possible. So starting from the course recording to editing to preparation of assignments and making them foolproof, preparing questions, making them foolproof, we need a lot of support from a whole lot of very efficient people who are working round the clock behind the scene to make all this possible in a very timely manner, and making the learning for all the students happen in the most efficient, effective manner. All this is for the students who have enrolled for the course, and I thank them a lot for being very supportive in joining the course and remaining enthusiastic all through the course duration, posting us with queries and doubts, which we have tried to answer and address as far as possible through these live sessions. And today brings us to the last live session of this course. It has been very enjoyable and also challenging to make this happen in the time-bound manner that it happens. And I hope that we'll be able to close all the activities associated with the course very soon when the exams are conducted, and finally those students who are planning to credit the course or get certificates out of this course come out successfully. And I hope those who are not appearing for the examination have also benefited from the course, have enjoyed the course contents. And I hope that that learning will be effective in whatever way it is, either it is for a student in academia or some industry personnel or research scientists. I only hope that the contents make their further course of study or profession more effective and successful. I'll move on quickly to one of the questions we saw in the Google forum recently, and it was related to internships. And one of the students had inquired about the possibility of internship opportunities. And then there was a question that Internship opportunities are generally offered to the toppers of the course. And to the best of my understanding, that of course depends on your exam performance as well as the performance that you have put in the 12 assignments that you have been doing. And I'm sure in the overall assessment that is done in terms of marks scored out of 100, the best performers are coming out successfully as the toppers of the course. Again, remember that internship opportunities are not purely based on becoming a topper, because it also depends on the interest of the faculty member in absorbing interns at that point of time. It often depends on the pre-existing commitments, responsibilities that the faculty member may be handling at that point of time, including students and scholars that the concerned teacher has to take care of. And beyond that, if it is possible, then of course it would be a pleasure to accommodate interns, but it doesn't always happen because of obvious reasons, as I already mentioned in the last minute or two. So don't be demoralized if it so happens that you are not able to top the course, or such internship opportunity does not exist at that point of time, but keep looking for such options and opportunities by approaching faculty members under whom you have done a course, even in future, or look for opportunities like project staff positions or openings like, say, doing more higher studies in the form of masters or doctoral programs in that particular institute under a concerned faculty. So there are a lot of possible openings which may occur not only at that point of time, but also in future. You have to keep your options open. You also have to be a little patient in terms of pursuing such activities. And it doesn't always happen at the point of time that you may be looking forward to, but sometimes waiting for a while, looking for the best opportunity that may be suitable for you, takes some effort, some time to materialize. So the main message that I would like to put through is that, of course, you should try for opportunities immediately after courses like this, but don't get demoralized if you don't find one at that point of time. Keep trying and be patient, be diligent, be persistent in your efforts. And it's often the long-term effort, the long-term perseverance that you demonstrate, which makes the difference. So that's what I would like to say with regard to this question, this posting. And I just put a screenshot here, which anyone can, obtain these details from the site that has been quoted, and it's quite informative. And I would suggest that you have a good look at it. For further clarifications, information, of course, our NPTEL staff are always there to provide you with such details. This is a point which I thought I would emphasize at this juncture, because it makes a lot of sense in trying to recapitulate that what makes a student eligible for a certificate out of a course like this. And then if you run through the rules which are actually posted in the site, you will see that you will be eligible for a certificate only if average assignment score is greater than equal to 10 out of 25. So they allocate 25% marks to the best 8 out of 12 assignments that you do, and 75% on the certification exam score. So the examination which is coming up shortly is a very crucial one in deciding how far you are going to score overall in the course, because 75% of it comes from here. And you're going to write this 100 marks paper soon, those who have registered for the examination. So I hope you all are preparing very seriously for it. And remember that in that examination, you need to score anything over and above 30 out of 75. And because the requirement is that both the criteria, that is one on the assignment side, the other on the exam score side, have to be simultaneously met. If any one of the two criteria is not met, you will not get the certificate, even if the final score exceeds 40, right? So you can see here that if you barely make 10 out of 25 or 30 out of 75, you will be able to reach that 40. And it's important that you satisfy those requirements individually for the two components. If you do so, automatically your bare minimum score should come to 40, and you also end up satisfying both the criteria, and therefore you become eligible for a certificate. So I'm sure those who are going to appear for the exam will definitely come out successful, but it's a good time to recap that what kind of scores one should look at if one has planned to earn a certificate out of this course. And remember that the certificate will carry your name, photograph, score in the final exam with the breakup, etc. It will have the logos of NPTEL and IIT Khanpur, and it will be available in e-copy. Hard copies are not going to be sent to you. And I'm sure that all of you who have registered for the exam will definitely earn yourself this certificate, which will, I'm sure, be very useful. Going over to the next very important point, that is the exam, the final exam that you're going to appear for. What kind of format are we looking at? So you need to look at the mail posted by the NPTEL team on 11th April 2024, which covers a lot of pertinent details. This will tell you about the final exam pattern, whether it will be a pen on paper exam or a computer-based exam. Remember that for your exam, for the exam that you are going to appear, it's not going to be pen and paper, it's going to be computer-based. So we'll discuss about it in the next 1 or 2 slides once again. But right from the beginning, I'm trying to emphasize the point that you should get used to these details. So there's a link which if you click, you will find that all the courses which are being offered in this Jan to April 2024, they will be visible. And in the 191 serial number, your course will be visible. So this is the course you are going to write the exam in, and you find that in the last column, they will display it as online computer-based, and that's precisely what you need to know. You'll have to appear at the allotted exam center and produce your hall ticket, which you may have received already by now. If not, then you will receive it very soon. And then you have to bring some government photo I card. There are a lot of options here. You should read through the rules. And definitely you have to appear in person for writing the examination. The final allotted exam center details will be available in the hall ticket that you will be receiving soon if you haven't received it yet. And for further details, let's move on to the next slide. So in the mail, there are some details which will be there towards the later part, which are not pertinent for you because they are applicable for paper and pen examination, and therefore I have struck off these portions. They are not applicable for you. You should prepare yourself to answer questions of the kind that you have found in the 12 different assignments that you have done. You very much should be recalling the formats, and you remember that there were questions both of the problem solving type as well as conceptual questions where you had to read the question statement and pick from the choices that were given to you. without doing any problem solving or calculations, but based on facts or based on concepts, you would have to answer them. Small calculations may be required to answer them, but not all such questions will be problem solving kind. Mostly multiple choice questions is what you can expect. And I would like to state time and again that you should be recapitulating the kind of questions you have solved in the assignments, which will help you prepare better for your end examination. Another very important aspect of the examination is that you should be familiar with using the on-screen calculator. And for that, you have got this on-screen calculator demo link, which you should explore. I have just added a screenshot of that calculator over here, but of course, the keys are not active here. The moment you open this link, the calculator that you find over there will be exactly the kind that you will see on the terminal that you used during writing the examination. So the important thing about this calculator is you should be familiar with using it, and you should also be quite quick in operating it. So having a little bit of practice on this on-screen calculator before you actually write the exam on your exam day would be really useful. You should be quite familiar with this use so that you don't end up spending much time operating it. While you prepare for the exam, revise the 12 assignments very well. I think I have already told a number of times over the last few minutes that this is extremely important, because this gives you not only the pattern of questions which you can expect, but it also gives you valuable practice of the contents of the course. And remember that at least a small fraction of the questions that you see in the final examination will be very much in line with the questions that you have come across in the assignments. So that will help you improve your score as well. You should not study the 12 weeks course contents selectively. That means on your own, don't try to leave out some of the week's contents because you are not too familiar with it, or you do not like those topics and so on. Have a reasonable amount of familiarity of the entire course contents. There may be a few weeks contents where you have a greater degree of confidence or familiarity, or just because you learned them earlier in some other course. So those could be your strong points, but you never know whether on the exam date you may find stiffer questions coming from those few weeks course contents and comparatively easier questions coming from other weeks which you left out. That's why selective study is something which is not encouraged. Please try to cover and revise your 12 weeks course contents as far as possible before you write the examination. Prepare both for numerical problems as well as factual and conceptual questions. And there may be small problems where a rough calculation may be required, but that can by no means be considered as a full-fledged numerical problem. So they would have a mix and match. And it is all right if you cannot attempt all the questions in the paper. Let's say if you have 50 questions carrying 2 marks each, covering 100 marks or something, then try to attempt as many as you can with confidence, and then take a call whether you would like to spend more time on the questions you haven't answered, or you would like to spend more time on revising the questions which you could do with confidence. So these are some of the things you should keep in mind, which is true for not only this examination, but probably most of the others. And like I have done in the previous live session, I once again very quickly am running through the distribution of topics over the course. And you may recall that in the first few weeks, we tried learning some of the theoretical aspects of aerodynamics. It's more like a storytelling that I'm going to do over the next few minutes, which if you listen to, you would recall most of the main things that you have learned or come across in the course. So we talked about three major components or approaches in modern aerodynamic studies. We said that when we look at the theoretical aspects of aerodynamics, we look for analytical or semi-analytical solutions. And then there's the experimental approach where we try to look at physical experiments which are set up using facilities like wind tunnels. And wind tunnels can be of different types. They can be separately configured for different speed regimes. They can be of the open loop kind. They can be of the closed loop kind, and so on. And low speed and high speed wind tunnels have different design features. They are meant for different speed ranges. They are meant for different kinds of experiments. And when we talk experiments, which we should also recall about models which are used for conducting the experiments, the different instruments that we use for conducting the experiments. What are the things that we try measuring? How do we visualize the flow? Are the flow visualization techniques identical for low speed or high speed flow? Measurements, we make measurements of pressure. We try to calculate velocity in the test section and so on. So there are a number of things we try doing through experiments. And then the area of computational fluid dynamics, where we try to do computations to find out what's going on in a flow field. Again, we have to solve some partial differential equations in order to obtain such solutions. And many a times, these three approaches may be mixed and matched and complementing each other, or one used for validating the other, and so on, when we try to apply them for studying some aerodynamic problem. Then we learned a little bit about the standard atmosphere, the different kinds of altitudes, geometric, absolute, geopotential altitudes. How do you define them? How do they compare with each other? And then the very important and interesting temperature distribution model through the atmosphere, approximately to an altitude about 100 kilometers from the Earth's surface. We saw that there are isothermal and gradient regions, and we saw how equation of state can be used to obtain pressure and density variation. And then came some of the important concepts related to aerodynamic flows, where we started discussing about pressure, density, temperature, flow velocity, skin friction. Each one of them were very extensively used all through the course in different contexts. And we started introducing these concepts from the first week. In this way, if you try to go through the different lectures, the write-ups, the notes, then you will find that revising the course content will become that much easier for you. And even if you do not find time to do very detailed preparation, at least regularly going through the course contents, trying to glance through the pages of notes, through the slides, etc., can be extremely useful to retain the course contents in your mind. And even through that kind of a revision, you will be able to answer a very good number of questions in the examination which follows. Those who are not writing the exam, even for them to retain the course contents in future so that they can apply it better in their subsequent studies or in their profession, having a somewhat regular revision of the contents is always very important and useful. After that, we had discussed about how the different forces occur on an aircraft. Why do they occur? How do they balance each other in a steady level flight? And then we talked about the concept of pressure and shear stress distribution on an aerodynamic surface, which when integrated gives rise to forces acting on the airfoil or moments acting on the airfoil. Similarly, you can extend that concept to a complete aircraft surface, a three-dimensional surface, not only a two-dimensional one like airfoil. And therefore, you would end up getting not only two forces and one moment, but rather three forces and three moments, like the one that we can see in the bottom left figure, where the different axes have been indicated along which the forces are acting or about which moments are acting. And then we learn to resolve forces based on angle of attack. We have these two expressions showing the connection between lift drag, normal force, and axial force, all of them connected through the angle of attack. We learned about very important coefficients like coefficient of pressure, skin friction coefficient, force and moment coefficients, and we learned how to distinguish them between 2D and 3D bodies by using lowercase and uppercase nomenclature. So all these things form a conceptual background, and many of these things were introduced in week 1. Week 2 further advanced that process, and we went into Eulerian and Lagrangian perspectives of the fluid flow. We defined control volume, and then we defined fluid elements, and we looked at the flow through fixed control volumes, or we looked at the flow by moving along with fluid elements. And then trajectories got defined in the sense of streamlines, path lines, and streak lines. And I hope you did some problems also to understand how each one of them is connected with another, and how do you derive these equations for these trajectories. Then came fluid kinematics, where we defined angular velocity, curl of the velocity vector. So you remember that we applied some of the vector concepts in defining these things. For example, curl of the velocity vector, of course, would involve some kind of cross product. Then came vorticity, strain of a fluid element, rotational and irrotational flow, circulation and vorticity, velocity, potential. So very important concepts, and the best way of recalling them would be that if you write down these terms on a piece of paper and then try to write down the mathematical expressions of each one of them, you'll get very useful kind of revision done. You need to check whether you are able to write them correctly, and also try to write them in terms of the components where there are multiple components, say in a vector. That will give you a lot of practice. You learned about a number of other operators like gradient, divergence. You learned about different integrals which are important in aerodynamics, applied to open and closed surfaces, and theorems associated with them. Most importantly, Stokes, divergence, Gauss, gradient, and so on. Then you learned about the conservation equations of mass, momentum, energy in their integral and differential forms. And again, in this week, a lot of fundamentals were there which need to be practiced well. So writing and practicing is the only way to perfect your preparation. We then introduced inviscid and viscous flows. We discussed about potential flow, boundary layer, and then we also learned to compare them and distinguish them, that how they are different from each other, where do they apply, which kind of flow assumption can be applicable for which region of the flow. In the same flow field, for example, if you imagine that the there's a flow past an airfoil surface, and if it is a viscous flow, you may recall that very close to the surface of the airfoil, there will be formation of a boundary layer, and the flow becomes essentially viscous in nature within the boundary layer. But as soon as you are beyond the boundary layer, the same flow will tend to behave more like an inviscid one. So these kind of concepts were discussed at length in this week, and further more detailing was done in terms of also use of some of the experimental procedures. For example, we introduced the pitot-static tube, and we saw how that may be used in obtaining the flow velocity in the test section of a wind tunnel. The same pitot-static tube can be taken through the thickness of the boundary layer from near to the wall to the edge of the boundary layer and beyond, and you will be able to see that there is a variation in the dynamic pressure that the pitot-static tube records, and try to recapitulate that why such a variation actually happens. So there are a lot of conceptual things that we did in this week as well, building up the ideas. And then we spent some time on airfoil geometry in the fourth week, where we started from discussing the basic idea behind the airfoil geometry, what are the geometric attributes of such a section, then some very important points like the leading edge, the trailing edge, then important line like a chord line or a curved line like a camber line. You also remember that the chord and the camber line will be identical if it is a symmetric airfoil, while they will be different for a cambered airfoil. You should be able to draw the CL alpha curve for a cambered airfoil and a symmetric airfoil. You should be reasonably aware of what we mean by the thin airfoil theory, for example, and also some of the theorems like the Kuta-Joukowski's theorem, the Kelvin circulation theorem, and also the Kuta condition that we apply at the trailing edge of an airfoil. You should be able to distinguish how flow past an airfoil is different from that of a bluff body, and a little bit about laminar and turbulent flow. When you studied airfoil theory, you also came across points like center of pressure, aerodynamic center. You should be able to define what these are. You also learned about potential flow theory in further detail here. You learned about elementary flows like uniform flow, point vortex, doublet, and a combination of these elementary flows, because all of them are solutions of the Laplace equation, and that happens to be a linear partial differential equation, and therefore individual solutions of that equation can be linearly combined to generate new solutions. In week 5, we extended our knowledge of airfoil to finite wing, and then we learned how the aerodynamics varies between an infinite wing and a finite wing. Where from does the induced drag concept come? How is the CL alpha curve different for an airfoil and a finite wing? Which has greater slope and which has less? And why is it so? And of course, basic understanding of the Biot-Savart law, vortex filament concept, how Prandtl developed his lifting line theory based on these concepts, and how does the horseshoe vortex, comprising of the bound and trailing vortex, help us model flow across a finite lifting surface. In the context of finite lifting surface, we recall about aspect ratio of a wing, different kind of wing plan forms which we came across, like elliptic wing plan forms, tapered wing plan forms, swept wings, things like that. In week 6, we started looking at compressible flows, and we started with full potential equation and its application, then gradually introduced the shock and expansion wave theory. We looked at flow through a CD nozzle, a little bit about transonic and supersonic flow past airfoils and shock wave boundary layer interaction, a little bit on shock tube and hypersonic flow as well. So we were essentially exposed to some of the basic concepts and entities of compressible flow in this week. And that made it quite distinct because still before this week, we hadn't talked much about high-speed flow aspects. In week 7, we talked a little bit about concepts related to computational aerodynamics. And there we tried to start from the panel and vortex lattice methods. And then we tried to go to the Euler and Navier-Stokes equations, and some amount of discussions related to Euler and Navier-Stokes happened in this week, and the rest we did it in the subsequent week. We learned how to extract information from numerical solutions. We understood also how computational aerodynamics can be applied to aerodynamic studies. So without going into much detail, these 2 weeks basically covered some of the elements of computational aerodynamics. And in the final lap of the journey, we started looking at experimental aspects of aerodynamics. We learned about wind tunnels, which happen to be the workhorse in the experimental aerodynamics discipline in week 9. Different aspects related to their design, their functioning, how they are applied for conducting different kinds of experiments in different flow regimes. These are the things we discussed and understood in week 9. In week 10, we learned about some of the visualization, measurement techniques, as well as model design and fabrication. We talked about different aspects of aerodynamic experiments, how to set up experiments, how to decide what to measure, and what are the different kinds of equipments which are to be deployed for the measurements, and how to interface all these equipments with the model which is placed in the test section and should be instrumented appropriately so that we can obtain the results from them. In week 11, we further expanded our knowledge more towards the electronic instrumentation part. In week 10, we had spent more time on the mechanical kind of devices, while week 11 brought us closer to the electronic measurement techniques in the domain of pressure gauges and balances, data acquisition systems, and so on. A little bit on measurement uncertainty also. And in the final week, we spent some time on particle image velocimetry, which is a non-intrusive technique by means of which we are able to obtain the velocity field information of a region of the flow. And we also showed some examples how wind tunnel and associated instrumentation are used for performing aerodynamic studies. And we, of course, did a quick revision at the end. So this kind of quickly sums up what we tried doing in the entire course. And we had a rather ambitious target to fulfill, and I hope that some justice has been done in that direction. And let me come to the end of this live session, the last live session. I hope we do not have too many unanswered questions. However, if you still have some queries, you can write to us in the Google forum. So I once again thank all the students, all the participants of the course for your very active participation. I hope you enjoyed the course and benefited from it. And I once again thank our entire NPTEL team, including my TA students and all the staff members of NPTEL who have made this possible. And last but not the least, our Government of India, Ministry of Education, who have been so supportive in making all these courses possible. I thank my institute, IIT Kharagpur, for supporting me time and again in offering these courses. So with that, I come to the end of live session 3. And I wish you all who are going to appear for the exam the very best. And the remaining students who are not going to appear for the exam, I will request you to keep in touch with the contents of the course and make the application of whatever you studied here more and more successful in due course. Thank you once again.
Thank you, sir.
You are welcome.